All right. Good morning. How are you all doing?
Good, how are you?
I'm back over here in Johnson City today. So, how's Cheyenne over there?
I'm good.
Good, good. Did you get your email from me yet from last night? Did you get an email from me?
No, I haven't gotten it yet.
Okay, all right. I'm sorry. I did not get the tests out to go to Kingsport in time. I didn't get them back in time yesterday, so I'd sent you an email with a copy of your test. But it is on its way, but I don't think it will get there in time today, okay? So I'm just going to say just a few things about the test today, okay? Whoops. I'm sorry, did you say something? I couldn't hear you.
I just said, okay, that's fine, thank you.
Oh, okay, we couldn't hear, okay. Okay, I just wanted to make sure. I'm sorry it didn't come through, though. I feel bad about that. I'm going to go ahead and pass them back over here. We're not really going to spend a lot of time today talking about them because there's other things we need to talk about as well. But I do want to talk a little bit about some things involving the test. So if some of you have maybe seen your grades on there, the grades were not overall very good. There were some good ones, though, so don't let me mislead you. But a lot of the grades were lower than I feel like they should be. Now, before anybody just gets up and leaves or something like that, which I hope you won't do, I want to just say that remember I am going to give you an opportunity to retake one test, okay? So when you do that, that would totally replace a grade. Let me go ahead and return these over here real quick, and we're going to talk about just some procedures about the test. I'm not going into detail about them today because Kingsport did not get theirs yet. After all, I know at least one of you over there got your test back because I got an email. So let me just say a few things about it. But anyway, give me just a second here. Let's see. Rachel McCall, Larry Moore. Now the graduate student graded these, and I looked back over them. I didn't go through completely and regrade though, but I'm sorry. You're here somewhere. You're close. One Ellswood, Brandon Delgado, Jonathan Beck, Evan Riley, Stephen Scheidler, Tom Zaleski, Chance Pritchett, Clay Carson, Zach Silman, Amy Spencer, Brent Rathbone, Gerald Rivers, Sydney Lawson, Aaron Mayer, Jacob Porter, okay, so I have sent a graded copy of your test through your email for you in Kingsport, and like I say, I'm not going to go through things today since you don't have yours in front of you, but here's a few things I do want to mention today about the test, okay? Overall grades appeared low when I looked at them after Mr. Sadiq, the grad student, had graded on them for me, and I am going to give you an opportunity, to retake a test. Let me put some dates up here in just a second here. Now, another thing, I have posted the answers to this test on D2L. What I would like for you to do between now and Tuesday is go on D2L and look at the answer key, okay, and try to see what you did there. Some of you have some notes on some of the problems, but there were a lot of problems that people were leaving blank. Okay, so look on my notes, not my notes, yeah, you could look back at notes, but look where I posted the key, and let's see what you think about that. And then Tuesday, I'll take questions about it if you still have questions. Or if sometime there you want to bring it and come see me, you're welcome to do that. You're welcome to take it to the tutoring center as well. Remember, my office hours are posted on the syllabus, which is on D2L. Okay, you have access to that. The CFAA hours are on there as well, or they're on the ETSU website, CFAA. I definitely want you to get some help with this test, though, somewhere, okay? Over on D2L, I'll show you where the answer key is there for just a moment, and you can take a look at that later. I'm getting into my site here. I'm not quite in there yet. Another word about this test. Okay, another word here. This test is always the toughest test of this class. It just is. This material is tougher, I guess, than whatever else we do, evidently. I'm not sure what makes it so tough. Maybe because we're thinking backwards with the inverse functions. Maybe that's it. I'm not sure. But it's always a little more tough than some of the other material. Under content on our D2L site, right here, you'll see where I posted that. The test 2 key is right there. Okay. And you should be able to download that and see problems worked out. Now, one thing I will say on that first page, I intended for those answers to be in radians. When Mr. Sadiq was grading, he gave credit if you put it in degrees. I didn't go back and take that credit off after he had given it to you, okay? When I did look through, I only gave back some things. So still, if you see something that you want to ask me about point-wise after class, feel free to do so. Or after you all get a chance to look at yours in Kingsport, let me know, okay? All right. So look over the answers, how it's worked out, and bring them back on Tuesday then, okay? Right now, though, as you're getting them now or as you get them in email over there in Kingsport, add up your points, make sure everything's adding up as it's written on the sheet, for one thing. Be sure about that. Any questions there? Okay, so let's go to some dates here. Today's November 6th. What does that mean? How much time do we have left? Okay, so like a month and 10 days. I'm hearing my little paper with my date. There it is. Just a little paper. So I have to look at that. So we're still going to have another test, okay? So it looks like, just to make things work fairly smoothly, on this Chapter 8 stuff and probably a little bit of Chapter 14 in it, we'll have to have test 3 in here before Thanksgiving. So that's Thursday, November 20th. It's 2 weeks from today. Not as much material on this test, though. Okay, so not quite as much. So let's get that date in mind. I'm giving you a chance to retake a test. I hate taking a class day to do it, but I'm going to give you a chance to retake one test on Tuesday, December 2nd. That way you'll have the Thanksgiving weekend, to look over whatever you're doing. At that point, you're starting to study for finals anyway, so that should be a help for you, right? You're studying for finals, you're looking back over old stuff. That should help you out there. In class, we will definitely review for the final. We'll have some form of review on Thursday, December 4th, which is our last regular class day. And then your final exam will be on Tuesday, December 9th, from 1:20 to 3:20. So that one's not an early morning deal. Okay, if anybody has a work issue, something like that, let me know. We'll figure something out, okay? You all would do that anyway. You'd let me know, wouldn't you? Okay,
Would you repeat that final for me, please?
What's up?
Would you repeat that final for me, please?
Yes, the final's Tuesday, December 9th, 1:20 to 3:20 is when we're scheduled for.
Okay, and that's a normal in-class final.
That's
correct?
what?
That is a normal in-class final?
Yes, it is. Yes, it'll be a normal, regular, in these classrooms final.
Wow, that's revolutionary.
Why's that?
I know so many of them are, doing other things, finals week. I don't know.
On computers and whatever.
Yeah, on the computers or the week before or not at all or I don't know. There's laziness, I guess.
I'm not going to be lazy.
Well, good. I'm glad to hear that.
Hey, They would like for me to be lazy, right? Y'all would like me to be lazy. But it's a comprehensive final exam. We're going to have it that last week during finals week, just like normal, and see what all we've compiled together for the semester, okay? So that's what we're going to do. Counts the same, though, as a regular test, okay? So it's not weighted any heavier in this class, so it counts the same. And it just gives you another chance to show me what you know about everything, okay? All right, so everybody's got the dates down? We've got a lot of dates coming up, things to do. We've got some material to finish, and moving right along, okay? All right, so let's go then back into section 8.1. And I think y'all were liking this section, weren't you, the other day? I couldn't tell when I was in Kingsport and I was looking at you all over here, I couldn't tell. The Kingsport students seem to like this material better, right? Everybody likes right triangles. That's a good thing. So let's look back in section 8.1. Now, there were some things in this section, though, that were probably a little bit new to you. Maybe solving triangles. Some of you may not have done that before. Complementary angle theorem, you may have not worked with that before. But hopefully we can get those questions answered today. Okay. So over on page 513, let's look and see what we might need to work on a little bit. This was where we were talking about Sohcahtoa. Also, as we called it, some old hippie caught another hippie tripping on acid. Y'all remember that part probably, right? Y'all did get that over here too, right? So however you want to remember it. Maybe you made up a new statement to help remember the Sohcahtoa. I don't know. Anybody want to share one? I guess not. Okay. So we're over on page 513, section 8.1. Okay. Somebody have one there that you would like for us to, kind of remind you how to do? Go ahead. Yeah.
Number 27.
All right, so number 27. We have cosine 35 degrees, sine 55 degrees, plus sine 35 degrees, cosine 55 degrees. All right, so one of the theorems we talked about last time was the complementary angle theorem. We said that it says cofunctions of complementary angles are equal. We said cofunctions are like sine and cosine, secant and cosecant, tangent and cotangent, the ones where we add co in front of them. So on here, I see we're working with two different angles, but I also noticed that the angles are complementary angles. They add up to 90 degrees. So it looks like we can use that theorem here by changing some of these functions to their cofunctions. So, for example, the cofunction of cosine here would be what?
Secant.
Not secant. Secant's the reciprocal, so do be careful. Sine is the cofunction for cosine, right? Sine and cosine are cofunctions. Now, reciprocal functions, that would be, when we, reciprocal functions, the reciprocal of cosine is secant, okay? All right, so cofunction here is sine, and the theorem says that cofunctions of complementary angles are equal. So the complementary angle, I think Brandon said, for 35 degrees is 55 degrees, which just happens to be, what we need. We need everything in terms of the same angle. So this is going to work out for us here. We're just going to leave sine 55 degrees. As it turns out, it looks like we're putting everything in terms of 55 degrees. Then we'll have plus, this one's not 55 degrees, so I want to change it to what? Cosine 55 degrees. The sine of 35 degrees is equal to the cosine of 55 degrees. Now, I did tell you all the other day, you don't have to believe everything I say. Most of you have a calculator. Punch it in and see. Sine 35 degrees, see what that is. See what cosine 55 degrees. Convince yourself. You all believe everything the calculator says, right? Maybe. I don't know. But convince yourself if you're, in doubt. And cosine 55 degrees here. Okay. Now, what do we have here then? Sine 55 degrees times sine 55 degrees is equal to what? It's equal to what?
2 sine.
It's not 2 sine 55.
Sine 55 degrees squared.
Yeah. Okay, it's the square of sine 55 degrees. We've got sine 55 degrees times sine 55 degrees. That's going to be sine 55 degrees all squared, right? But we know in trig we write it sine squared 55 degrees. plus this part over here is going to be cosine squared 55 degrees. And then all of a sudden, we remember, here's what we're thinking, here's our mind right here in the red box, okay? All right, we remember sine squared theta plus cosine squared theta equals 1. So that tells me that this stuff I'm working with here equals 1. Okay? The sine, when we square the sine of an angle and we square the cosine of an angle and add those together, we always get 1. Okay? Can I do what?
13.
Yes. Hold on 1 minute. This one makes me think of something else. So I'm going to go into just a little bit more detail here on this problem, okay? Just a little bit more details, a little background on this, because I'm just thinking to myself here, okay? I'm thinking if we have a right triangle, and we have in that right triangle, let's say a 35-degree angle and a 55-degree angle, because we know if we've got the right angle, it's 90 degrees. The other two would have to add up to 90 so that all together they equal 180. And if I wanted the, let me label this A, B, C. If I wanted the cosine of 35 degrees, which side over which side would that be on my letters? B over C, right? If I wanted the sine of 55 degrees, sine is opposite over hypotenuse, what would that be? So without using the calculator, are you convinced they're the same? Cofunctions of complementary angles are always equal, okay? This is how they work out when you're in the right triangle setting there. All right, so there's actually another way we could have done this problem. Let me add that too. There's another way we could have done this. Anybody think of another way? Well, we had a formula back in chapter 7, that chapter that some of you didn't like, but we had a formula that said sine alpha cosine beta plus cosine alpha sine beta. Remember that formula? Doesn't this look kind of like that? Now it's rearranged a little bit, but what if I wrote this? Let me come over here. Alternate for number 27. We have cosine 35, sine 55. Here's how the problem's stated. But I'm thinking, you know, that kind of looks like one of those sum or difference formulas. So, you know, do I have to write it this way, or can I say it's sine 55 degrees, cosine 35 degrees? Is that the same as what I had there? Yeah, I'm multiplying. It doesn't matter which order I multiply in. This is just making it look more like the formula. And then if I say cosine 55 degrees, sine 35 degrees, this now looks like sine alpha cosine beta plus cosine alpha sine beta. Doesn't it look like that formula? What formula was that? It was the sine of alpha plus beta formula, which for us here, that would be the sine of, what's my alpha and beta?
55 is alpha, 35 is beta.
Oh, yeah. I put them down wrong from what I'd written up here. You're right. 55 plus 35 is the sine of 90 degrees, which is also 1. Okay. So I want to encourage you, instead of just leaving these, well, that's section 8.1, and this was back in section 7.3. Yeah, the book's split up in sections, but I hope that somehow we connect those sections, okay? I want us to somehow see, you know, some of these things work together. It's not just, even though we set it up chapter by chapter and that's how we learn it, they do all connect in some way, okay? Try to look at the big picture there. So we might think about this one for number 27, you know, that we could have used the last chapter on it and made a connection there. But, you know, really, truthfully, they wanted you to use the complementary angle theorem like we did the first time through. That's what they wanted you to do. All right, number 13, right? That's where we're headed. Is everybody finished with this page right here that we're on? I forgot to set it. Get out the roll sheet. So here, let me pass that. All right. Number 13. We have a triangle drawn for us. Up there's angle theta. Here's 2. Here's 4. There's the right angle. We want to find the values, the exact values actually, of the 6 trig functions here. Exact values. We said, we don't need a calculator for anything exact like that. So we want to work with the angle theta. Sine of theta is always the opposite side over the hypotenuse. A little bit of a problem here. I don't know the opposite side from theta. If that's theta, then this over here is the opposite side from it, right? The side across from the angle is the opposite side. So I've got to find that.
I just use x.
You just want to use x. Okay, that's fine. 2 squared plus x squared equals 4 squared. Whatever you call it, we're using the Pythagorean Theorem to get that side. Okay. 4 plus x squared is 16. X squared is 12. X is going to be the square root of 12, which is 2 square roots of 3. Okay. We okay so far? We found the missing side. So the sine of theta then must be 2 times the square root of 3 for the opposite side over the hypotenuse, which is 4. And we would need to reduce that. What's it going to reduce to? Square root of 3 over 2, right? Because 2 into 4. Okay. Cosine of theta. The cosine is always the adjacent side over the hypotenuse. The side adjacent to theta is which side? 2 over hypotenuse 4. That reduces to 1/2. Tangent is going to be opposite over adjacent. Opposite over adjacent is whatever what?
2.
2 square root of 3 over 2. That simplifies to give me just the square root of 3. Okay. Cotangent of theta. Well, that's going to be 1 over the square root of 3. Go ahead and rationalize it. I get square root of 3 over 3. Okay. And the secant is still the reciprocal of the cosine, so that will be 2. And the cosecant is still the reciprocal of the sine. So it looks like that's going to be 2 over the square root of 3. And when I rationalize that, I get 2 times the square root of 3 over 3. Okay. All right. Any questions on getting the 6 trig function values there? This is the part that some of you may have done before, this part right here. The rest of this section, I don't know if you've done before or not. And some of you may not have done this either. I don't know, because everybody comes from different past experiences there. But if you've done anything in this section, it's probably this type of thing right here. Any questions on 13?
Can we do number 29?
Yes, let's go to 29. So I wanted us to do one where we were solving the triangle, and this is one. So we have side B is 5, angle B is 20 degrees. Find the rest of them. That's what we're doing. When we solve the triangle, even if they don't tell you, if it says solve the triangle, then you're finding the remaining sides and angles. They give us a drawing here. They don't always give you the drawing, but if they don't and you're drawing it, and you label it however you label it. Let's say I go ahead and label it. I'm doing it like the book has it so that yours will look the same. But across from angle A, I will have side A. Across from angle B, I'll have side B. And across from angle C, I will have side C. Okay. They told me that side B is 5. They told me angle B is 20 degrees. They also showed me that angle C is a right angle, so it's 90 degrees. We already know that part. So we're looking for angle A, side C, side A. Those are the things we're trying to find, okay, to solve the triangle. What are you going to find first? Probably angle A, because you know angle A is going to be what? 70 degrees. Those angles in the triangle have to add up to 180 degrees, so you know that angle A is going to be 70 degrees. Let me write that in here too. Now, we need to find either A or C on the sides, one or the other, and we're going to use a trig function to do that, one of the right triangle trigonometry functions there. Okay. Which one do you want to use? You have some choices, so somebody pick one for me. Or if you tried one but didn't get it to work, let me know what that was.
The sine of 20 degrees.
The sine of 20 degrees. Let's see what that gets us then, okay? The sine of 20 degrees. And usually there's more than one choice of what we can use at this point, so just try something because your goal is to have just one missing piece of this equation now so that you can solve for it. Sine of 20 degrees, sine is opposite over hypotenuse. So the side opposite 20 degrees is going to be which one?
B.
Yeah, side B, which is 5, over the hypotenuse, which is C. So that will work. We're only missing side C. We know how to solve the equation and get that. How are we going to solve the equation?
You get C on its own.
Okay, how am I going to get C on its own? I want you to be real specific with me, okay?
Multiply both sides by C over 1.
Okay, multiply both sides by C. Okay, so that those cancel. So now I have C sine 20 degrees equals 5. Divide by the sine of 20 degrees. So that the sine of 20 degrees cancels on that side, and we have C equals 5 divided by the sine of 20 degrees. And then you can break out your calculator, okay, because I didn't bring one, and make sure the mode is in degrees. I want to make sure about that. It does make a difference. And do 5 divided by the sine of 20 degrees, and let's see what that's equal to.
14.62.
14.62, and is that rounded to the hundredths? Okay, thank you. 14.62 is approximately what side C is equal to. Is everybody okay on that part?
Why couldn't you just divide by 5 at the very first?
Why couldn't you just divide by 5 at the very first? Where, you mean on this step before I did anything else? Well, C was in the denominator, so if I divided by 5, let's see what I would have. Let me come up to the side a minute. I had sine 20 degrees equals 5 over C. If I divided by 5, then I've got sine 20 degrees divided by 5 equals, what does this give me over here? Yeah, 5 over C divided by 5 is the same as times 1/5, so it gives me 1 over C. Okay, you see what's happening there? It's giving me 1 over C, so I'm still going to have to flip both of them and get, well, then 5 over the sine of 20 degrees equals C. My advice is to actually write out the algebra and be very careful, okay, because you would have had the opposite division going on, okay. So let's take that part back off there. I just wanted you to see what happens, though, if you do that. Write out whatever it would say according to the trig function. Sine of the angle equals opposite over hypotenuse and solve from there. Okay, use the algebraic steps to solve. What about side A? What are we going to do about that?
Pythagorean Theorem.
Okay, Pythagorean Theorem will work. So we've got A squared plus 5 squared equals 14.62 squared. So that's A squared plus 25 equals 14.62 squared. A squared is going to be 14.62 squared minus 25. I'm letting you all finish the rest of that. Tell me what A is. You all get A squared and take the square root of it.
13.74.
13.74. Y'all agree with that? Is everybody getting 13.74? Okay. See, a few of you are. Some of you aren't there yet, so let me give you just a minute to get there. You got it?
I got 188.74.
And then did you take the square root of that? Is that what a squared was equal to, I'm guessing?
Yeah.
So then when you take the square root, because you're going to get a squared equals, tell me again what you got for a squared from this calculation here, 188 point something. And then if you take the square root of both sides, you have to do that to get a. Okay, to see what side a would equal. Also, remember that there's a correspondence between those angles and sides, that the longest side has to be across from the largest angle, where our largest angle here is going to be the 90-degree angle, and the longest side is going to be the hypotenuse, or should be. If we get anything besides that being longer, then something's wrong. The shortest side will be across from the smallest angle. So it doesn't tell you exactly what it should be, but it tells you if your answers make sense, right? Do these answers make sense? The shortest side is across from the 20-degree angle. The longest side is across from the 90-degree angle, right?
Yeah.
So at least they look like these could be answers. Okay. It doesn't guarantee that we got it correct, but they could be answers. I think you all got it correct, though. All right, anything else from that part right there, from page 513? Yes. All right, 47. So for an example of one of the word type problems today, it says a right triangle contains a 25-degree angle. If one leg is of length 5 inches, what's the length of the hypotenuse? Let's draw some of this. Always when they're wordy, you want to draw something. Okay. A right triangle contains a 25-degree angle. First, they told us it's a right triangle, so we know we've got to have a 90-degree angle. It contains a 25-degree angle. Okay. If one leg is of length 5 inches, what's the length of the hypotenuse? If one leg, it doesn't tell us which one, but if one leg's 5 inches, what's the length of the hypotenuse? There's the hypotenuse. Can I use just that information and get that hypotenuse? Which trig function would I use? Tangent's opposite over adjacent. I don't know my opposite side, right? Can't use tangent right now. What can I use? Cosine. The cosine of 25 degrees, cosine is the adjacent over the hypotenuse, so that would be 5 over c. And again, we're going to be multiplying by c to clear that out. And c is going to be 5 divided by the cosine of 25 degrees. And you're going to get, I don't know what you're going to get.
How do you know the
5.52. Go ahead.
How do you know that the 5 inches applies to the adjacent, not the opposite?
We don't know because they didn't tell us. We don't know. But look at part B. It says there are 2 answers. How is this possible? So you just answered how that's possible because they didn't tell us which leg was 5. So it does make a difference. So let's find the other possible answer. Okay. This is one answer. It could be that. It could be that we've got that angle that's 25 degrees and we put the 5 over here, right? Still, that's going to be the hypotenuse. Now what would we use to get side C? Yeah, now we'd say the sine of 25 degrees is the opposite over the hypotenuse. So we'll multiply both sides by C. And then we'll divide by the sine of 25 degrees. To get that side C could be, or the hypotenuse could be what? 11.83 inches. Okay. We have 2 possible answers because it will depend on where that side is or where we put the angle. You know, if we leave the side the same, we'd place the angle different. But the placement of the angles and sides are going to matter. So that's why there are 2 possible answers there. It's kind of a strange question, maybe. we're thinking about those right triangle trig functions, right? Sohcahtoa and how to use those. That gives us a little start maybe on 8.1. If you had some questions, hopefully you can go back and answer those. We're going to move on up into section 8.2 today. 8.2 is the law of sines. Okay, so we've got a new law we're working on now. The deal is not every triangle is a right triangle. We like right triangles. They're convenient, but not all triangles are right triangles. If we don't have a right triangle, we can't use the Pythagorean theorem, and we can't use the right triangle trigonometry, the Sohcahtoa stuff. It doesn't work if it's not a right triangle. So we have to have other methods to solve or find the missing sides and angles when we have oblique triangles. So first, let's put up what oblique triangles are. And this is section 8.2 in your textbook. Basically, oblique triangles, they just don't have a right angle. Okay, no right angle. And that's what they tell you on page 517 in your book. If none of the angles of a triangle is a right angle, the triangle is called oblique. So when there's no right angles in a triangle. We'd only have one right angle per triangle anyway, but if you don't have a right angle, then it's an oblique triangle. So we've got to have some other methods to solve those. And what we typically use here are the law of sines and the law of cosines. The law of cosines is in the next section, but today we're looking at the law of sines. Now, in order to use the law of sines, you must know an angle and the side across from it. In order to use that law of sines, you've got to know, you'll have to know something else too, at least one other part, at least one other angle or side, but you have to have one correspondence where you know an angle and the side across from that angle, or you won't be able to use this law of sines, okay? The law of sines looks like this. The sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. That's actually the law of sines right there. What it's telling us is that the sine of an angle over the side across from it is in proportion to the sines of the other angles and the sides across from them, okay, the ones that correspond here. That's why we have to know at least, one angle and the side across from it in order to work with this law of sines. If we don't know that, then probably we're going to use the law of cosines, okay? But we don't know that today, right? So when can we use it? When we know certain situations. Y'all remember geometry? Some of you remember back in geometry. Did you all like geometry or not? Some yes, some no. Okay, I get it mixed in here. You talked about different types of triangles or where you knew different things, like angle, side, angle. Maybe those were the parts that were given to you, right? Side, side, side. Remember those things? Okay, so let's see what we would have to know then in order to use the law of sines here. Let's say I've got a triangle, and my triangles may still look like right angles, or like they are right triangles, but they're just triangles, okay? Remember, nothing in here is drawn to scale. So always remember that. All right, so let's say I know this angle, this side, and that angle. So I know angle, side, angle. Could I use the law of sines? Do I know an angle and the side across from it?
No.
It might look like I don't, but do I? If I know two angles in the triangle, then don't I also know this one? It wasn't given to me, but I would know it. So I could use the law of sines. What's that? It doesn't matter what they are. We don't know what they are. So they could be 45s, but we don't know that. No, but we're trying to talk about oblique triangles, and if they were both 45, then the other one would have to be 90. However, the law of sines does work for right triangles too. Okay. You can't use right triangle trigonometry on an oblique triangle, but you can use law of sines on a right triangle. Okay. All right, so if we've got angle, side, angle, then we can use that law of sines. That works okay. Because just by default, where we know two angles of a triangle, we know that other angle. What if we have it like this? What if we know side, angle, angle? Is that different from this? Well, I don't know. Let's see. Side, angle, angle. If that's what we know, can we still use law of sines?
Yes.
Yeah, there it's a little more straightforward. We've got an angle and the side across from it, right here. We know that angle. We know the side across from it. Okay. But see, they're in a little bit different order of what we know, because this one was side, angle, angle. And we've got to go right in that order when we're labeling our triangle there. What if we know side, side, angle? So we know side, side, angle. Can we use that? Yeah, we can use it. What if we know side, angle, side? How can we find the third side? We might not be able to, because if it's not a right triangle, I can't just find the third side, right? Pythagorean theorem doesn't work if it's not a right triangle. So I cannot use law of sines on this last one, because I don't know that I don't know the side across from that angle that I'm given, and I don't know those other two angles. So this would be one where I would have to now use law of cosines. So I'll go ahead and label it, even though we haven't mentioned it yet. And what if I know the other one we mentioned a while ago, side, side, side? I don't know any of the angles. It goes with law of cosines. Okay. I don't know the angles. Do you have to remember all these? No, you don't have to remember all these, okay? I'm just wanting you to think about them when I put them up here. But what you do have to look at whenever you're given a triangle and you're asked to solve it, you have to look at, do I have at least one of the angles and the side across from it, along with whatever other information I have? If I do, then I can use the law of sines. Okay, that's what we're checking for. You don't have to remember all these things right here. Okay, just to make you think about it a little bit. So let's try to use that law of sines then to solve a triangle over here. Let me find it on here. This is over on page 524, this example is. It's number 10. It looks like this. It's a triangle. This angle's 40 degrees. This angle's 45 degrees. They're telling me that this side is 4. And then they've labeled this angle up here C, and they've labeled these sides A and B. Let's label the other angles and the other side that's not labeled. Okay? Just for the heck of it, because I told you we've got to have some correspondence going on here. So how are we going to label these things? The 40-degree angle should be labeled what? What letter? B. Angle B must be across from side B. It has to be that way. Okay? The 45-degree angle then must be labeled A. And the side that's 4 would be C. Right. Okay, so angle C is across from side C, angle B is across from side B, angle A is across from side A, always when we label these things. It doesn't matter if it's a right triangle or an oblique triangle, we want them labeled that way. Okay, with that correspondence. It doesn't matter if I start and go A, B, C, or A, B, C. You know, that doesn't matter as long as I've got that correspondence set up, okay? That's going to be important when you're labeling some of these that they don't already have drawn out for you. And there are some like that. Now, this one here, what's my other angle? Because if I'm solving this, first thing I see is that I can know what angle C is. What's it going to be?
95 degrees.
It's 95 degrees. How do we know that?
180 minus 40 minus 45.
Yeah, 180 degrees minus the 40 degree minus the 45 degree, right? All the angles in a triangle always have to add up to 180 degrees. So we're all good on that one, right? We got that part. All right, so that one is 95 degrees. So is this a right triangle? No, it's not a right triangle. All right, how can I find side A or B? Well, we got to remember the law of sines. Tangent of what? Who said? And what would I do? Tangent of 45 degrees would be what? What's wrong with that? The question is, I don't think you all heard it, the tangent of 45 degrees equals a over 4. That's only for right triangles. I'm not in a right triangle. It's no good anymore, okay? But that's the problem here. When we switch over, we still want to think the right triangle stuff because those are the nice ones, really, aren't they? Those are the good ones, but that doesn't work in this part. Okay, so sine of the 45-degree angle then over side A equals, and now we need the one where we know the angle and the side. What's that going to be? Sine 95 degrees over 4. Even though the law of sines is written out showing that all three sines of the angles over the sides across from them are in proportion, we only have to solve with 2 things at a time, okay? That'll make our lives a little bit easier there. So we've got a proportion set up here. The sine of 45 degrees over A is equal to the sine of 95 degrees over 4. That's what we want to solve. We only have one missing piece there. So how am I going to solve this? Y'all remember proportions? Yeah. See what she's doing? This. We're going to cross multiply. If you have fraction equals fraction, then it's true that their cross products are equal to each other. So this is where we can cross multiply. I'm going to say this equals that. Okay, so 4 sine 45 degrees equals A sine 95 degrees. I do not need my calculator yet because I don't want to round these things within the problem and then round again at the end. I want to round as little as possible, okay? So right now I'm just going to do the algebra, and then at the end I'll get the calculator out, or you all will, and tell me what you get, okay? So I'm trying to get A by itself. What do I need to do? Right, divide by sine 95 degrees, because I'm trying to get rid of that part right there. And do the same over here on the left. So now I have 4 times the sine of 45 degrees over the sine of 95 degrees equals A. And let's round that to, I guess, 2 decimal places will work. So A is going to be approximately equal to what? 2.84, okay. So A is approximately 2.84. Okay. So this is just a new way of solving triangles. You know, if we know different information, they're oblique triangles. We still got to find side B. How are we going to find side B?
Just do the same thing with the sine 40 degrees over B equal to sine 95 over 4.
So just do the same thing. Except now we're going to say the sine of 40 degrees over B. We got to use that side B. So the sine of angle B over side B is equal to, still we can use the sine of 95 degrees over 4, or you can use what you got, but we'll just go with the same idea here. We've got 4 sine 40 degrees equals B sine 95 degrees. And so 4 sine 40 degrees divided by the sine of 95 degrees is going to be what B is. So what's B? .58. Does it make sense that side B would be a little bit less than side A? Because angle B is a little less than angle A, right? So that makes sense for us there. So B is 2.58. What do you think about the law of sines? Any comments on law of sines? It's not too bad, is it? Take a little practice. It's probably new to most of you. Any questions so far on this problem? So we're going to say sine of the angle over the side across from that angle equals sine of some other angle over the side across from it. And then we're going to cross multiply, okay? Set the cross products equal. Go ahead.
So we're always going to know one side, either A, B, or C, to have to work these out, correct?
Right, you'll have to know one side and the angle across from it in order to work these out. That's correct. Yeah. Okay. Let's try another one here. Let's try one where they don't give you the triangle, because I want to make sure you can draw a triangle here for me. This one's 22. 22 is angle B is 10 degrees. Angle C is 100 degrees. Side B is 2. Okay. They didn't give us a triangle this time. They just say solve the triangle. Okay. Draw and label for me. And then let's compare. All right, so do we have a drawing? And yours and mine may not look exactly alike depending on where you put your angles, but just let's make sure that we have the same things across from each other, okay? The angles and sides that are across, as long as those match, we're in good shape. All right, so angle B, it tells me, is 10 degrees. Angle C is 100 degrees. Angle A, I don't know. Whether or not you labeled yours this way, just make sure you've got the same things across from what. So the parts I'm going to put now, make sure that across from angle B, across from that 10-degree angle, you have side B equals 2. Across from angle A, you have side A. And across from angle C, you have side C. Everybody sees what I mean about across from or opposite those angles, right? Any questions about what I'm talking about there? The side across from an angle, it's just the side that the angle is opening up to, okay? Are we okay on our drawing? We see this is an oblique triangle. It does not have a right angle. But what is the measure of angle A? Yeah, 70 degrees, because that would cause the angles to add up to 180 degrees. We've got that part done. We know that one. Can we use the law of sines? Well, of course, we're in that section, right, in the textbook. But yes, we can use it. How do we know?
Because you have an angle, the one across from it, and a third point.
Okay, so we have the angle, the side across from it, and we have some other information, right? So we've got the sine of 10 degrees over 2 equals, and which one do you want to find first? A or C? Okay, so the sine of 70 degrees over A. Okay, that's what we're going to solve right there. So A times the sine of 10 degrees equals 2 times the sine of 70 degrees. So A is going to be 2 sine 70 degrees divided by sine 10 degrees, which is approximately equal to 10.82. Did y'all get 10.82 for side A? Good. Side C, you can use the same way, and I'm just coming over here to the side like we did before. I'm still going to go with the sine 10 degrees over 2 equals sine of 100 degrees now over side C. Okay. So what do we get here? C sine 10 equals 2 sine 100 degrees. C is 2 sine 100 degrees over the sine of 10 degrees.
I got 11.34.
Okay, 11.34. We were expecting that side to be the longest side because it's across from the largest angle. Okay. Does everybody agree? I'm trusting y'all's calculators out there. That's good. Now, there are some word problems to go with these as well, but there's also one other little catch about these law of sines problems. You all knew it seemed a little bit too easy, right? There's one catch. Okay. There's one case that we call the ambiguous case. And in the ambiguous case, it means that the information they give us could allow for more than one drawing to occur based on the information given to close up and form the triangle. It could allow more than one triangle to form. Specifically, there could be two ways for us to get a triangle. So that if we're solving certain triangles, we would want to know both possible solutions for those triangles. It could be that the information given to us, though, could only result in one triangle, like these right here. These do only result in one, the ones we've looked at so far. And it could be that the information they give us, that there's no way to realistically connect those measurements up if only we had like real toothpicks or sticks or something to put together and see. You know, in here I didn't bring those, though. But there may be the cases where we get no triangle. So this is the ambiguous case that I'm referring to. And the ambiguous case refers to back here where we were looking back on this part. This one right here is going to be the ambiguous case. The ones we've worked with so far have been the other two cases, okay? The way we know is when we are given this side-side angle, that's ambiguous. To help you remember it, though, I'm going to call it the ass case. I'm going to switch the letters around, okay? So it works the same, but you'll remember it better that way, right? Yeah, I think you'll remember it. The ass case is the ambiguous case, okay? So when you see this case here, where you've got angle, side, side, and actually in the textbook they're telling you in the directions, determine whether the given information results in 0, 1, or 2 triangles. You know you're working with the ambiguous case. We're going to see an example of how are we going to know which one we're working with, okay? So let me go down here to number 34 a minute. Oops, here we are. Okay, so number 34, let me put one more thing over here, can result in 0, 1, or 2 triangles. So 34 is over on page 525 here. Here's the information we have. B is 4, C is 5, angle B is 95 degrees. The question is still, solve the triangles. Okay, this part says two sides and an angle are given. Determine whether the given information results in one triangle, two triangles, or no triangle at all. Solve any triangle or triangles that result. Okay, that's what the directions tell us to do. Let's draw it. I just like to see the drawings, okay? So I'm going to do it this way, A, B, C, which will make it like this. I know C is 5, B is 4, angle B is 95 degrees. So the deal here is that there's a chance that we could have other angle measures besides just, you know, what we first end up with. This one's different. How is this one different to you when you first look at it from the ones we saw before?
I know that C is going to have to be bigger than B, angle-wise.
Okay. You know the angle C is going to have to be bigger than angle B because side C is larger than side B. That's a good observation. What's that? If it is what? It'll be more than... If angle C is bigger, it'll be more than 180 degrees. That's a problem, isn't it? But we're seeing from what we're given, and we know how that works, you know, that an angle and a side, they have to have that correspondence, right? Let's see what the law of sines tells us. And that's a very good observation, though. Okay, let's see what law of sines tells us here then. It's obvious we can use the law of sines because we have an angle and the side across from it. So let's work with that a little bit. We've got the sine of 95 degrees over 4 would have to be equal to, well, it looks like the only thing we can work with is that C business, right? Sine of C over 5. This is just the information they gave us. It's already been noted that, you know, according to the way it looks, angle C has to be larger than angle B because side C is longer than side B. But if angle C is even a little bit larger than 95, if it's even 95.1, we've got a problem here, right? So you might notice that because that's going to lead you to believe that this this information will form 0, 1, or 2 triangles. 0, right? This is leading me to believe it's 0 triangles. But if I don't notice that, let's suppose I don't notice and I go on into my law of sines. Let's see what happens. I've got 4 times the sine of C equals 5 times the sine of 95 degrees, which tells me the sine of C is equal to 5 sine 95 degrees over 4, right? How would I get angle C from that? We'd have to do the inverse sine, right? All this stuff over here. The inverse sine of 5 sine 95 degrees over 4. See if you can put that in your calculator. Still should be in degrees on this one, okay? I think we've already pretty much established in everybody's mind that this is not going to work for a triangle the way it's set up. What does it give you? Error?
Yeah, I got an error.
Yeah, it's an error. That's what happens on the calculator. It tells you error, and that tells you, no, this doesn't work. So we know that there's no triangle. So even if we miss seeing that observation, which y'all are very quick on that, that's real good. But this one's no triangle because you get that error. Okay? It's not going to let it happen. It can't happen. Notice I was given here, I'm going backwards now, angle, side, side, to help you remember the ask case. Okay, but it's side, side angle, okay? So when I'm given that, I will know it's the ambiguous case, and there's a chance that I could get 0, 1, or 2 triangles. What else was different about this one? When I asked you a few minutes ago, what else was different was on the ones before, we already had 2 angles given to us. So those triangles with the 2 angles already given, those are already pretty much, you know, formed how they're going to be. We know what that 3rd angle has to be. Here it's a little more ambiguous because we have 2 angles that we were not given yet. That's what makes the ambiguity there. Okay, so when we just know the 1 angle, we're going to kind of be on guard here, okay? This one's a no triangle case. Let's try one that will be 1 or 2. Go ahead.
So on these ambiguous cases, are we always going to have to use the inverse sine?
To find an angle, you'll have to use the inverse sine, right? So anytime you're looking for an angle in a triangle, you will end up using that inverse trig function, right? That's true. Well, let's try another one here, okay? Let's try this. Number 30 says B is 2, C is 3, angle B is 40 degrees. Again, I only know 1 angle here. So I've got A, B, C, 40 degrees, B is 2, C is 3, I don't know A. It's an ambiguous case. I know that it's going to be 0, 1, or 2. I don't know which. I guess looking at this right now, I can see that angle C has to be a little larger than angle B, right, because of the sides. That's going to work, though, isn't it? So far we're good. Let's set up our law of sines. Sine 40 degrees over 2 equals the sine of angle C over 3. So far, so good, right? We have 2 sine C equals 3 sine 40 degrees. The sine of C is 3 sine 40 degrees divided by 2. So C is going to be the inverse sine of 3 sine 40 degrees over 2. So what does that give us for angle C? 74.62 degrees. Okay, is everybody getting 74.62 degrees? We're getting that? Good. So we know it's not going to be 0 triangles because we're getting an answer. So we're going to have at least one triangle, right? If we're getting some angle value, we're going to have at least one triangle. So C is 74.62 degrees. Yeah.
Can we still do the 180? Can we add up the angles?
Now we can still add up these two angles we know to get one, to see what else we need to get 180 to figure out angle A. Yes. So what's angle A going to be? You can go ahead and tell me that then. That means angle A will be 180 minus 74.62 plus 40, whatever those add up to. 65.38 degrees. So we know we're getting at least one triangle. We'll go ahead and solve this one, then we'll come back and figure out how we're going to check and see if there's another possibility, okay? So A is 65.38 degrees. Everybody agree on that part? All three angles have to add up to 180. Are they adding up to 180? Yep, I see it. They're adding up to 180, so that looks good. All right, we got to find side A. How are we going to get side A? Back to the law of sines, right? The sine of, we can go back to the one we started with if you want, sine of 40 degrees over 2 equals sine of 65.38 degrees over A. A sine 40 degrees equals 2 sine 65.38 degrees. A is going to be 2 sine 65.38 degrees over the sine of 40 degrees. That's what I'm dividing by this time, right? So what does side A have to be? 2.83? Okay. And we solved getting at least one. We know there's at least one. We still have to check, though, and see if there's going to be another option for us here. So that's the part we need to see now. To check and see if there's going to be a second triangle that could be formed, to check for second possibility, I want you to do something for me. You all have your calculators out, right? Do for me the sine of 74.62 degrees. That's 74.62 degrees. Do that for me.
Okay.
You got that?
That's 0.96.
Okay, 0.96. Is that what you got? Sine 74.62 degrees equals 0.96. Okay, now do the supplementary angle for 74.62 degrees. So take 180 degrees minus 74.62 degrees. What does that give you? What is it?
105.38.
Yeah, the rest of the angles we had up in our triangle, remember? Up there. What's the sine of that? 0.96. That's the key to checking for another triangle. The deal here is, you know, we've got to have these proportions. The sine of an angle over the side has to equal the sine of an angle over the side, but the sine of these supplementary angles are the same. So the question here is, when we first got the first angle we came up with right here, that angle C, when we got that one, that's where we want to check. We want to say, whenever I look at the supplement of that angle, which would give me the same sine value and still be in proportion, can that supplement value be a possibility for angle C? Let me redraw what we were given right here. Just a moment. Okay, we had, how do I have it drawn again? There we go, ABC like that, okay. So we had B was 2, C was 3, B was 40 degrees. Okay, we found C was, 74.62 degrees. But to check for a second possibility, take 180 degrees, it's always 180 minus the angle you found, to get, what was it again, 105.38 degrees. Could angle C equal 105.38 degrees? Could angle C up here equal 105.38 degrees? It can. How do we know it can? Well, because we can still get something for angle A and make the three angles add up to 180 degrees, right? Now, if I'd gotten that supplement, though, and I got something like, I don't know, let's say I got 150 degrees, and these other things still have to be true. Angle B still has to be 40 degrees, right? And if I'm coming up with 150 degrees, then no, that's not going to work, and we're just going to say, it's just the triangle I already got. I'm finished with this one. It was just one triangle. But here, if the supplement is also a possibility, then that gives us our second triangle. So we look back at the information we were given, but this time instead of putting in that 74.62 degrees for angle C, we're going to use 105.38 degrees for angle C. And the answer here is yes, because we can still find angle A, right? Basically, there's still room for us to put in the third angle. What would the third angle be? If I've got 105.38 degrees plus the 40 degrees I have to have, that's 145.38 degrees. So angle A has to equal 180 minus 145.38 degrees. So that's what? 34.62 degrees, right? So angle A could be, it's given us a second triangle here, which we can also solve. We are solving as we go through this. This only happens with the ambiguous cases, okay? This only happens when we know that angle side-side or side-side angle, where we've got the one angle, we've got two angles open there. People are waving to me outside the window. Okay, so that's the only place it happens, so we want to watch for that. We want to check. If we are getting one triangle, go ahead, solve that triangle, but then check, can I get a second one? To check and see, you're going to take the first angle you found, because you had to find an angle. You're going to find the supplement of that angle, because their signs are the same, and see if that is an option for that very same angle you just found. Remember, it was angle C we found originally? That's the one we're looking at here also, to put the supplement in for. How do we find side A? We didn't finish side A. How do we find that?
Use the law of sines.
Yeah, go back to the law of sines now. So now we're back to sine of 40 degrees over 2. I don't know, I just like to use the one that they gave us first. Equals the sine of 34.62 degrees over A. So to save a little space here, A is going to be 2 times the sine of 34.62 degrees when I cross multiply, divided by the sine of 40 degrees. So what's A going to equal? So we'll have this one solved then. What's A going to be there?
7.7.
What is it?
1.77.
Okay, 1.77. That's a very small side, isn't it? But look, the reason is, look at my triangle there. Remember, it's obviously not drawn to scale, because what does that 105.38 degree angle look like? Oh, yeah, it's an obtuse angle, right? So we're going to have something more of a flattened out triangle there. And we're going to have a very long side. Well, it's not very long here. Our triangle looks small, but we're going to have a much longer side on one side than we do on the other, okay, based on the way the triangle is kind of smashed down there. But there are two triangles that result from this problem back here that we were looking at, okay? You don't know that on appearance. You only know when you check the supplement of the first angle you're looking at. See what you can do with those. Some of those may be tougher to work with than others. and we will talk about them a little bit more at the start of class on Tuesday. I'm also going to ask you to try a couple of these word problems just to see what you can do with those as well. And let's see. Let me list some up here for you. Over on page 524 to 525 in section 8.2, let's try numbers 9 through 35 odd, and then I'm going to pick and choose a few of these others here. So let me choose number 39 and number 41. And how about, let me go over here. There's another one I wanted here. How about, we'll put up 47 also. Okay, so those last three are word problems, but try some of those. See what you can do with those. Also, don't forget, over the weekend, take a look at your test. Compare it with the answer key that I posted on D2L. Okay. Let me know if you have questions, okay? Everybody all right? Have a great weekend.